In this video, I'm going to take you through Euclid's division algorithm, which is theorem 2 in chapter 2 in the Samacheer Kalvi maths textbook. But before we get into the theorem, let's see an illustration. It's always easy to learn with illustration and then understand the theorem. Let us consider two numbers, number A to be 273 and the number B to be 119. Let's use Euclid's division lemma, which is A is equal to, this is Euclid's division lemma, A is equal to BQ plus R. And let's substitute the values of A and B here. So we get 273 is equal to 119 times Q. We need to find Q plus R, and we need to find R. So 119 times 2 will be, keep balance 1, 3, 2, 238. So subtracting 273 minus 238, you will get this to be 5 and 3. Okay. So you will write here times 2 plus 35. So now our Q is equal to 2 and our R is equal to 35. What we're going to do is we're going to take the B and the R. Okay, so B and R, and we're going to apply the same Euclid's division lemma again. So which means our B will become A. So 119 is equal to, our B will be R now. So it's 35 times, let's find out what is this number, plus you will have a reminder here. So 35 times 3 should give you 105. And 119 minus 105 will give you 414. So we can now say that our Q is 35 times 3, so it's 3, and our remainder was 14, so it's 14. Now let's do the same method again, which is take our V and our R and again repeat the same process. So repeating the same process, you will get 35 is equal to 14 times plus the remainder. And 14 times 2 will be, 14 times 2 will give you 28, and 35 minus 28 will be 7. So we write here 14 times 2 plus 7. And then repeating the same process again. Now our A will be 14 and our B will be 7. So 14 is equal to 7 times 2, and your remainder will be 0. Let us apply our results onto the theorem. Okay, now step 1 in the algorithm says, using Euclid's division lemma, A is equal to BQ plus R. So we have here A is equal to BQ plus R, where our A is 273, our B is 119, and our Q is 2, and our R is 35. Okay, where Q is the quotient, and R is the remainder. If R is equal to 0, so it's the condition says if R is equal to 0, then B, let's highlight it. It says if R is equal to 0, then B is the highest common factor of A and B. Okay. So let's come here. Our A, our B, our Q, and R. But it says if R is equal to 0, or R is not equal to 0. So if it's not equal to 0, what happens? Otherwise, in step 2, it says, otherwise, applying the Euclid's division lemma, divide B by R to get B is equal to get this. B is equal to RQ1 plus R1. So let's apply here. So our B becomes the new A. So let's move our B. So B becomes our A. And our R becomes the B. So our R will now become B. Okay. So this is our new A, B, Q, R. So it says that if R1 is equal to 0 in step 3, then R is the highest common factor of A and B. So if R1, which is our 14 here, is equal to 0, then B, which is 35, is the highest common factor of A and B. But however, our R is 14 and it's not equal to 0. So what does step 4 say? Step 4 says, otherwise using Euclid's division lemma, repeat the process until we get 0 remainder. So we're going to repeat the process, which means now our A will be 35, our B will become A, and this will become our R will become our new B. So again, applying this A, B, Q, and R. And our R is 7. So we need to get this R to be 0. So let's apply this one more time. So applying, now you can see clearly that this B becomes our new A. And this R will become our new B. Right? So when you do this, what do you get? You get your R to be 0. So here your R is 0. So if R is 0, then this B that we got, which is 7 is the highest common factor of 273 and 119. Let's do example 2.4. If the highest common factor of 210 and 55 is expressible in the form 55x minus 325, find x. So first we need to find the highest common factor for 210 and 55. So our A has to be greater than B, so that is equal to 210, and our B is equal to 55. So let's write it in the form of A is equal to BQ plus R. So that is 210 is equal to 55 times, we need to find this number, plus the remainder. So 55 times 3 will give us 55 times 3 will give us 165, and 210 minus 165 will give you 45. So that is 45. So let's repeat it. According to the division algorithm, you need to keep repeating. So now our B will become A. So moving our B as A, 55 is equal to, and our R will become our new B, 45 times plus remainder. So this will be 1, and 1 times 45 is 45. 55 minus 45 will be 10. Our remainder will be 10. So let's repeat again. 45 is equal to 10 times dash plus dash. So our quotient will be now 4. 4 tens are 40, and the remainder will be 5. So let's proceed to do it again. 10 is equal to 5 times 2, and our remainder will be 0 here. Now we can establish that 5 is the highest common factor between 210 and 55. Now what are we expected to find? We are expected to find, or rather prove, to find x, where 55 x minus 325 is equal to 5, which is the highest common factor. So simplifying this equation, we can get 55x is equal to 325 plus 5, and that is equal to 330. So our x is equal to 330 divided by 55, and our answer will be 6. So we have our answer, x is equal to 6.